Hello, good afternoon, and welcome to the deep dive session for S3. My name is Umair Gilani. I'm a product manager for the S3 team, and helping me out is Carl Summers.
My name's Carl. I'm a software engineer with S3. Spent a couple years on the front door of the REST API, and most recently been developing the event notifications features.
All right, so let's get started. We have a lot to cover today. This is a deep dive session, so we're going to try and keep it as detailed as possible. But there are a lot of new capabilities we've added to S3, so we're going to be focusing a lot on that as well. I'm sure there's going to be questions at the end. Carl and I are going to be here for as long as it takes to answer any questions. We encourage you guys to come up and talk to us, give us your feedback, and we'll answer any questions as well. So with that, let's get started. So let's start with a bit of trivia. On the slide behind me, there's all the storage services that AWS offers as part of its storage portfolio. Who here can tell me which one of these services launched first? Oh, S3, yeah. You are in the S3 session. Both of us are part of the S3 team, so it's a little bit of a hint for you, but that's right. S3 was one of the first services that launched, first storage services that launched for AWS. But as you see here, this kind of leads you to how we think about storage all up at AWS, right? For us, it's about freedom of choice. Very early on, we heard from customers that not all storage and not all data is built equal, right? Data comes in different formats, and as such, it requires different capabilities from its storage. You have data that's file-based, and you need file-based semantics in your storage in order to use that appropriately. You have block storage, which you might want to use your compute for persistent storage. And then, of course, you have object storage as well, which we have S3 and Glacier for. But we really want to continue to make sure that we offer the right breadth of capabilities for our customers so that the right kind of data, in many cases, more than one type per customer, goes in the right kind of storage. And it's not just about adding breadth to storage as well, right? We make sure that we continue to innovate in each one of these storage services. S3's been around the longest, but even then we'll see in our session today that we continue to innovate, we continue to think about how to make it easier for customers to get more value from their data on S3. Another aspect, especially as we keep working with our customers through their journey of migrating their data from on-premises to the cloud, is how do we transfer information and how we transfer data from on-premises to the cloud and back. And there's a number of different services that we are continuing to invest in that help you move your data from on-premises to the cloud and back. You have the ability to use Direct Connect to establish a high throughput link between your on-premises network and the cloud. Last year we announced Snowball, and for this summit you can now move up to 80 terabytes of information by getting this Snowball shipped to your device, to your network, connecting it to your network, and then moving the information to the device and shipping it and getting it directly to your data lake in S3, where you can then start getting a lot more value from that data by using all the great ecosystem that we provide around it of services and capabilities. We work very closely with our ISV partners to make sure that all the on-premises storage appliances that you guys know and love work seamlessly with AWS and S3. We also launched Kinesis Firehose, which allows you the ability to stream data directly to S3 or Redshift and stream terabytes and terabytes of information specifically for those IoT-related use cases. And for this summit, we also announced S3 Transfer Acceleration, a new service that allows you to leverage the broad network we have for CloudFront and upload data faster to S3 by using the network that CloudFront has and reaching out to your closest point of presence. And we'll talk a bit more about this, but there is a dedicated session as well for this at the summit, so I would encourage you to go look at that as well. And then, of course, we have Storage Gateway as well, which allows you to work seamlessly with your network and the cloud. So a lot of breadth in terms of services, a lot of innovation in each one of these capabilities, and of course, we're going to be focusing on S3 for our session today. But before we move on to some of the new capabilities we've launched, though, I wanted to kind of take a minute and talk about our core customer promise. Really, customers think of S3 as the place to move data where I know it's going to be there when I need it. I know my data is going to be reliable. We promise 11 nines of durability, 4 nines of availability. So when I need my data, it's going to be there available for me, and it's going to scale seamlessly. We're working with customers starting with hundreds of petabytes all the way to exabytes, right? And having that ability to scale up seamlessly to that level is a big part of what we provide. We regularly peak at millions of transactions per second and have trillions of objects in S3. And that scale really makes my job very interesting because a lot of energy that we put in any of the capabilities that we add to the platform go back to our core customer promise to make sure that we have that 11.9 of durability, the 4 nines of availability, as well as being able to handle S3 scale, right? It's one thing to add a replication capability that says, you know what, I'm going to replicate even billions of objects from one bucket to another. A very different engineering problem when you're saying it could potentially be, and it is in many cases, trillions of objects. So how do you design a system that scales at that while still giving you the same performance, while still giving you the same durability and availability? So that's something that we continuously think of on the team, and just want to kind of touch base on that is that, you know, this is our core customer promise, and in any of the capability that we provide, we make sure that we are true to that customer promise. So with that, let's talk a little bit about some of the great innovation we've been doing in S3 over the past years. I'm not going to go in detail for each one of these in the interest of time, but again, if you have questions around this at the end, you know, feel free to come talk to us. We'd love to hear your feedback around this. Now, one of the feedback items we hear from a lot of our customers is, you know, I put data in S3 and that's great. I need to be able to use that data. I need to be able to derive value from this data. And a big part of that is using S3 as a data lake so that I can leverage all the great capabilities and services that AWS has to offer. True to that, one of the capabilities we built last year was event notifications on S3, where you have the ability to add a configuration to your bucket, which then triggers a notification on put events or delete events, depending on what you configure, and delivers it to multiple destinations in AWS. You can send a notification to SNS, you can send it to an SQS queue and pick it up for your application and perform actions on that, or you can send it to a pre-configured Lambda function, which is compute in the cloud for us, which scales dynamically, and then you can take specific actions on that. There's a lot of very interesting use cases we're seeing customers build with this. The more common ones are, I want to be able to transcode my file, so when a new file does show up in S3, maybe I want to create a thumbnail or re-encode that the video in a different format and so forth. Or I want to build a secondary index, right, in DynamoDB, so when a new object gets put, I want to trigger a Lambda function that then goes and updates my index. And of course, when the object gets removed, I want to take action as well. So there's a lot of very interesting things that you can do with this event-based computing paradigm. And AWS is definitely committed to that, and as is S3, and we continue to innovate. Another capability we added there is the ability to filter by prefixes, so not only can you trigger a notification for the entire bucket, but for a specific prefix. Another capability we launched is cross-region replication, specifically for those use cases where you have compliance-related requirements where you want a copy of your data hundreds of miles apart. We do work with a lot of financial customers who need to make sure that, for compliance reasons, their data is hundreds of miles apart, some specific geographical distance, or that I want to move a copy of my data closer to my users. So that when my end users access this the object, they see the best possible performance because it's actually physically closer to them. Another use case is protecting against a rogue actor, right? So if we see customers giving access to their logging information, for instance, to all of their organizations, so people can move fast and use that information, but at the same time, creating a copy of that or replicating a copy of that in another region which is locked down just to the administrator provides that extra protection as well. We also have VPC endpoints, and we launched the ability, we launched VPC endpoints for Amazon S3, which with VPC endpoints you can create, with VPC you can create a closed network within S3, your private cloud, and make sure that your application cannot be accessed from the outside world and vice versa. But a lot of these applications do use S3. So in that case, you then had to set up an internet gateway or manage NAT instances. With VPC endpoints for S3, however, you only need to put a VPC policy on your VPC endpoint, and then without your traffic having to go over the internet, you are able to talk to the specific S3 bucket that you set up. And that's important, right? You need to be able to configure which VPCs talk to which buckets, and which buckets have permission to allow API calls from a specific VPC. You can control both of these using VPC policies and a combination of bucket policies there. Now, as S3 grows in scale, one of the feedback items we hear from customers is, I need a better way to understand how much data I have on S3 and how that's actually changing. Responding to that, we launched the ability to, we actually launched specific CloudWatch metrics for S3. You can now, for free for all buckets, you can now monitor the object count for your bucket and see that trending over time, as well as byte count for standard, and frequent access, which is our new storage class, as well as reduced redundancy storage. So really kind of get an idea of how my storage is changing over time. We also integrated with CloudTrail. So for bucket level API and configuration requests, you can now track when a specific API call was made, what was the response, who was the person making that, which gets added to your CloudTrail log, so you have that available for auditability, and you can go back in time and see who changed what configuration and when. We also increased the bucket limit for S3. By default, you can create up to 100 buckets in your account. And we find that for most use cases, that's actually more than enough. There are certain use cases, however, where increasing the bucket limit is required. So if you think that you need higher bucket limit, open up a support ticket. We'll work with you to make sure that we increase your limit to an appropriate number that you require. Now, S3 is a distributed system, and as such, we are eventually consistent, which means that if you delete an object or if you update an object, it will be eventually consistent, and eventually you will see the latest version of that object. However, we heard from customers that specifically for new objects that are coming into S3, it would be great if I can get read after write consistency, which is if I put an object, I want to be able to read that new object immediately and take action on that. So last year, we announced that for all regions and all endpoints, we have strong read after write consistency. You are still eventually consistent for read after update and delete and other operations, however. So just a quick look at some of the capabilities that we've been working on. Of course, it doesn't stop there. We also launched a new storage class last year, which we're seeing great adoption and great feedback on, which is standard S3 infrequent access, and I'll actually go in more detail for this. We also, this year, just announced 2 new lifecycle policies that help you manage your data better. The idea behind lifecycle policies really is that for those repetitive, cumbersome tasks around cleanup and managing the life of individual objects, especially at S3 scale, the more of that work that we can take away from you, the customer, the more you can focus on building great applications and workloads on top of S3. And true to that, with lifecycle policies, we now have 2 new policies, one for expired object delete marker, and again, we'll go in more detail as we progress with the presentation, and also another policy for incomplete multi-part upload expiration. And as I mentioned earlier, we launched a new service for S3 transfer acceleration, where we leverage the great network we have with CloudFront, as well as other network optimizations to increase the upload speed of your data up to 5x, depending on network conditions. And it's actually very easy to use with S3 as well. There's basically 2 steps that you need to do in order to use transfer acceleration. One is set a configuration at your bucket level to enable transfer acceleration. And then for your specific put API where you want to use this, simply change the endpoint with the name transfer acceleration in there. And that's about it, right? Other than that, you don't need to make any changes to your application, and it's actually very easy to use, and we'll make sure that your data gets to S3 in the fastest possible way. So let's dive a bit deeper into the new storage class, transfer acceleration. The way we think about this is for specifically active workloads, we've had S3 standard, and customers know and love that, where you have the best possible durability, the best possible performance, and for regardless of how actively you use this data, the standard infrequent S3 standard is the best storage class for that. On the other end of the spectrum, though, you have archive data, right? Data that's cold, you're not really using it. You really want to make sure it's durably stored, but you don't need it immediately, right? For that, of course, Glacier is the best possible choice. The way we kind of see a lot of workloads play out, and talking to a lot of customers, is data and its characteristics change over time, right? So I might have an object, let's say a video that I upload, which is a training video for my enterprise, perhaps. I upload that to S3. It's training season, so everyone's looking at that. Or there might be a document that I'm working on with my colleagues, and so it's a new document. I'm actively working on it, and it's very actively being accessed. But over time, there's going to come a point when I want to archive it and have it available, but not actively use it. But that doesn't really change overnight. It's not a flip of a switch, right? Over time, these characteristics change, and the data is still important. The video is still important. People are still looking at it, but it is less frequently accessed. And so that's really where standard infrequent access comes in, is that the storage class is specifically designed for data that is less frequently accessed, of course, but when you need it immediately. So we wanted to make sure that you get the best possible performance for this, but you do save on storage cost because this data is less frequently accessed. There's a number of very interesting use cases we're seeing with this. Sync, file, and share is one that I talked about a little bit, for documents. Backup and archive, specifically with disaster recovery, is very interesting because I might be backing up my data, but when I need it for disaster recovery purposes, I really need it immediately. I don't want to wait for that data because this is about business continuity for me. So I need access to that immediately, even though it's a very unlikely scenario. And similarly, long retained data such as log data, we're seeing a lot of that, where I might not be either retaining the data earlier, now I have the storage class, and this data, specifically logging, is something that I might not actively use, right? If there is an issue with my application, I really, really need this information, I need it right away because it's an operational issue. But odds are that I don't run into that issue, and that means that this data is going to be very infrequently accessed. And there's a lot more very interesting use cases we're hearing from customers around this as well. So let's look at some of the characteristics for standard infrequent access itself. We wanted to make sure that as a customer, when you put data into S3, you never have to worry about losing that information, right? So across the board, from standard to standard infrequent access in Glacier, you get the same 11 nines of durability. Durability is exactly the same as standard. Standard infrequent access is designed for 3 nines of availability, which means 99.9% of the time when you access this object, you will get it. But if you don't, you can issue a GET request immediately after and get your object. But we also wanted to make sure that you get the same performance, right? And that's very important for our customers, and that's what we heard from customers too, is that yes, this file is less frequently accessed, but I don't want my end users to pay for that in terms of user experience. So when my user requests a file, he should get it with the same performance as you get for standard, and that is what we've delivered. You get the same throughput as S3 standard. Another very important aspect for us is ease of use. Not only can you keep objects within standard infrequent access, and Glacier within the same bucket, you don't need to change the prefix, the location, or your API for that, right? So you don't need to make any changes to your application. You simply tier data from standard to standard infrequent access, and your application just works. Security is always top of mind for AWS and S3, and as such, we added a lot of capability around security and encryption over the years. You can encrypt an object using server-side encryption. You can also bring your own key and encrypt an object even before you put it in S3, or you can use KMS-managed encryption keys as well. S3 standard infrequent access works with all of these, just like standard does. And it's also integrated with all the different capabilities we continue to add and innovate on S3, right? Such as the Lifecycle platform. It works with versioning just like standard. You can fire an event notification from standard infrequent access just like you can with standard, and any other information such as metrics you get with the storage class as well. But one very common sort of question I hear from customers around this is, it's great that I understand that I can put infrequently accessed data into SIA or standard infrequent access and save on that. But more often than not, I have specific workloads or applications running within the same bucket under different prefixes. So how do I know which one of my prefixes are infrequently accessed and which ones are not? And for our demo today, we're going to answer that specific question using all the capability that's available today in S3, which is server access logs, right? You have server access logs, and have had this for a while, where you can enable this logging functionality in S3, and all of your API calls are logged in a log file within your bucket. But those are specific API requests with timestamps, right? So we're going to look at the demo that Carl has set up, which actually leverages one of the very common use cases for S3, which is big data on S3, and we've written a small big data job that then processes these logs and gets us to the specific insight we're looking at, which is which one of my prefixes should I actually tier to SIA given the data. So with that, let's look at the architecture real quick of what we're going to be showing you guys. It's actually 7 simple steps. We are going to enable access logging, a free capability available. We're going to put the logs in our data lake in S3. We're going to leverage the power of EMR and write a very simple Spark application that's actually going to aggregate these logs by the R and filter by operation. So we can filter out the total number of gets per R and then visualize those and the total number of puts and so forth. We also want to make sure that we filter these out by response code, right? So if I want to make sure that the successful gets is what I look at. We're also going to persist the interim results onto S3, a very common usage pattern with big data jobs, where customers, once you've projected structure on your data and pre-processed this information, you don't want to do that again because you might have to come back to this either for the same or different analyses. So it's a great best practice to actually persist that interim data, such as a Hive table, for instance, onto your S3 bucket, so that your big data job can actually start from there and save a lot on time when you run that analysis. And of course, we're going to persist the aggregated results in S3 and then use a bunch of visualization tools to drive insights from this aggregated information. There it is. All right.
Not quite.
So let's start with enabling access logs for our bucket, right? So once you go in your bucket, under properties, you have server access logging available. You can simply use the UI, just click enable. You can put the access logs either in the same bucket or a different bucket, and also specify a specific prefix. And this is where S3 will then start generating access logs for you. So let's look at the logs themselves to get a feel for what that logging information is. And that really is, for every single API request you get to S3, we're going to log that information, as well as interesting information about that, right? Such as the turnaround time, or what was the response code for this, right? What was the bucket and the prefix that we were accessing this under? So this is what your access log actually looks like. If we just highlight one of these, we can get a feel for what they look like. So you have your prefix, you have your timestamp, on when the specific operation, the specific API call was requested. You have your operation. This was a put, right? And then we have the response as well for this, and turnaround time and so forth, right? So this to kind of get you an idea of what access logs actually look like. Of course, this by itself doesn't give us the answer of which ones of my prefixes are infrequently accessed, right? So that's where we need to get to as part of our demo. So next step then, we're going to start setting up an EMR job, and we're going to use Spark for that. It's super easy to set up. We just created a new cluster, right? Or we're creating a new cluster, give it a name. Logging, again, you can enable this and put it in your data lake, which is S3. But we're just going to keep that up. We're going to use cluster as the launch mode. We will pick the latest version. For applications, we can select all applications, although we could have selected Spark as well, because it is a Spark application. Let's pick an instance type. We could leave this as M3XLs and then pick the number of instances, again, depending on the amount of logs that you have, depending on the overall traffic that you have, which, by the way, you can, and the amount of data you have, which, by the way, you can see using CloudWatch metrics as well. And then we will set up the security and access for this and just hit go for the cluster. Let's not hit OK for now. We have a pre-baked cluster for you to go look at. All right, so we've set this up already. And the next step then is to add our Spark code, right? So let's take a look at the code that Carl has put together for us. It's actually fairly simple. All this code does really is pull the raw access logs from S3, project structure on it, and to start parsing these logs. And then we actually aggregate the logs up. Right? We are saving the interim results here, by the way. So this was one of the best practices that I talked about, that once you've done the pre-processing of your logs, it's a great idea to persist that in S3 as well. So the next time I spin up this cluster, I can probably just start with the pre-processed data. I don't need to parse that again. This next file looks at prefix aggregation, right? So over here, what we're doing is looking at how do we want to add this up, right? So we looked at the access logs. It was specific access requests, right? You see a put, you see a get, and information about that. What we want to be able to do is add it up by prefix, because we wanted to answer the question by specific prefixes. We want to add it up by R, otherwise it's just going to be too much information. So I want to see total number of put requests for a given prefix for R1, 2, and 3, and so forth for a given R. But status code is also important for us, because you want to filter out unsuccessful requests versus 200s and so forth. So 400s you might want to filter out. And then we kick off our map reduce job to actually go ahead, and then at the end of the day, we will persist the final results back in S3. So that really is the extent of the code that we have in 2 files. And so now let's add code to our EMR cluster, right? So we will add a Spark application, give it a name, and then give it our input options. So in our code, if you noticed, we had two parameters. We have the input location of where my raw logs are located, and then another one for output location where, where do I save? What is the S3 location where I actually save my final log? So let's go ahead and copy these arguments over that we have here. Right. So notice that in our arguments we specifically specify S3 as our input and output location. All right, now the jar files have been uploaded again into S3, and then we can simply just, once we specify this, we can simply hit add, and this will go ahead and add the Spark application to our prefix, to our cluster. So EMR is super easy to use. In fact, let's actually go back to our presentation and talk about some interesting best practices when it comes to leveraging EMR for S3. There we go. Right, so EMR is super easy to use, but there are a lot of key benefits you get by leveraging EMR with S3. First and foremost, S3 allows you to separate your compute from your storage from your compute, which really means that you have the ability to resize or shut down your EMR cluster completely without ever having to worry about losing data, because that's in S3. Additionally, you can actually point multiple EMR clusters to the same data in S3. So that's, these are key sort of value adds that S3 brings to the table, in addition to the great durability and persistence of your availability of your data. Another best practice is leveraging EMR-FS with EMR. EMR-FS is an implementation of Hadoop, which is optimized towards writing and reading directly from S3 for your EMR cluster. And there's a number of great capabilities that this actually brings to optimize your big data jobs, your Hadoop jobs. First is it provides you the read after write consistency. In addition to that, it actually has optimizations in it where it makes the list performance faster, specifically when you want to kick off your job. And given the volume of your data, you might have to wait for a bit, whereas with EMR-FS, they have optimizations built in to make your list perform much faster. They also have some error handling. Really want to make sure that as far as your big data application is concerned, you have transparent access directly to S3. And then, of course, the other advantage is any and all capabilities we have in S3 you get to use. For instance, encryption, right? You can use server-side encryption on your data. You can use client-side encryption or KMS key-based encryption, all of those, as well as Lifecycle. So all of those capabilities that we've been talking about and are going to talk about, you can actually leverage with your big data job. So for instance, for your temp files, you don't need to delete those. You can set a Lifecycle policy that will take care of it for you, and so forth. So just kind of pointing to some of the best practices when it comes to using EMR-FS with S3. So let's move back to our demo and let's start with looking at the output file, right? And so once we do the aggregation we talked about, which is aggregating by prefix and operation and the time, aggregating it within a 1 hour time slot, and the operation and the response code, what does the output file actually look like? So you see here, we've transformed our access logs from a specific API request to, for this given prefix, I have, and for this given R, 2100R, I had 5 get API requests, which were successful, right? Which had a 200 count, and so forth. And you see this for all the different timestamps that we actually analyze this for. Now, if you were to put this in a pivot table, so get that. And what we did is we just put it in a pivot table, and we filtered it by the access frequency, by the count. So we pivot table, we did it by the count, and we can actually see the different API requests. So if you were to visualize that pivot table, you see here that each one of these graphs shows you, for a given R, the total number of GET requests, successful GET requests. So I see here the prefix in blue, for instance. Over time, it is seeing a very high number of persistent GET count, the dark blue one, whereas the light blue one is still high, but it is tapering down over a larger amount of time. Whereas on the left bottom side, the green and the reds are very low-hanging fruit, where yes, they did peak to about 100 gets for an hour, but very quickly they tapered down. So for this specific workload, maybe it was logs that I had there that I analyzed for the first few days, and then I'm kind of done with those. or whatever else is low-hanging fruit, and now I know specifically which one of my prefixes are infrequently accessed. Now I can actually leverage lifecycle policy to actually go back and make sure that we tier these out. So let's actually take a look at that real quick. So if you go to our bucket.
You want to do that?
Yeah. So if you go to our bucket, for our given prefix, I don't think we see these back there.
I don't know. Oh, that's
There we go.
Sorry.
All right. So if we go to our bucket, we can actually set the lifecycle policy for the specific prefixes that we know are now infrequently accessed based on our analyses. Right? So we can simply go in, specify the specific prefix, and given the data that we saw, we can say, in 60 days or 30 days, whatever we were able to see, you can now expire with a lot of high confidence because you know that your access data actually tells you that this specific prefix is infrequently accessed. All right. So let's move back to our presentation and talk a bit more about lifecycle policies, right? So, so for lifecycle policies, as I mentioned earlier, really the goal is to take as much overhead for housekeeping and managing the lifecycle of your data away from customers, making it simpler to manage data, especially at scale, right? And there's two possible actions you can take in lifecycle policy. You can either transition to standard infrequent access or Glacier, or you can take an expiration action and delete objects, right? Specifically for those use cases, maybe I set up my big data job with S3, and I know that the temp files I don't want to keep for more than a week, right? And so you can actually expire objects based on lifecycle or expire them yourself as well. You do have the ability to combine multiple actions. So in our demo, we set a specific lifecycle policy for a given prefix. We can actually go set other lifecycle policies for the same bucket in other prefixes as well. So if you look back to, can you move to the next one, please? All right, so if you look back to standard infrequent access, as I mentioned earlier, it fully supports the lifecycle capabilities. You have the ability to transition from standard to standard infrequent access, and then from standard infrequent access to Glacier based on your usage pattern that we just looked at as part of our demo. You can, of course, expire objects that are standard infrequent access, just like you can all other storage classes, and it works with versioning supported as well. But another thing I wanted to call out is while you have the ability to transition from standard to infrequent access, and for a lot of workloads it actually makes sense that your data is frequently accessed and it changes characteristics to be infrequently accessed. There are a lot of cases where it makes sense to put data directly into S3, and you have that ability when you put an object, you get to specify the storage class, and you can specify standard infrequent access as one of those storage classes. So if I do know I have logs that are not going to be used as frequently, I can just put them directly into S3. So here's a sample lifecycle policy, just to kind of drive the point home on how easy it is to set up. Over here, I'm setting two transition actions. The first transition action that's highlighted, I'm actually transitioning data that is 30 days old, regardless of the storage class, into standard infrequent access. And then in the next slide, I'm going to talk, in the next slide, we see here that we are then transitioning data that is a year old into Glacier. Right? So both of these policies work together to actually make sure that your data moves between storage classes. But again, remember that you never have to change anything in your application. Neither did you have to change the location of your data as it moved from standard to standard infrequent access to Glacier. All right. So let's look at another best practice that we recommend our customers, which is versioning. Right? We talked a bit about this as well. Versioning is a capability that allows you to protect against accidental deletes and overwrites. And the way this really works is you can enable versioning at your bucket level. And once you do that, if you put an object and then you put another version of another, essentially you try and overwrite the object, S3 will not overwrite it. It will actually make the current version non-current while still keeping it, and then simply just put the latest version on top of that. So now you actually have all versions of your object, and you can always recover or roll back, right? So if you accidentally overwrote an object, no problem. You can always just delete the latest version, and then the one you have, you can make your current version and so forth. So that really kind of gives you that additional protection. but against those accidental deletes and overrides. There are 3 states for version buckets. By default, versioning is not enabled, so you do have to enable that for your bucket. Once you do enable versioning, the state changes from to versioning enabled, and that is when S3 will actually persist all the versions of the object. You can also suspend versioning, in which case we will not remove any of the existing versioned objects, but if you do additional puts, they will not be versioned. Now, one very common sort of feedback item there, and one very common use case and usage pattern we see with versioning and lifecycle together is the ability to get recycle bin. Now, I want to make sure I protect against accidental deletes, but at the same time, I don't want to keep all versions of my data forever. And if that is what you want to do, you can combine lifecycle policies with versioning. You can enable versioning on your bucket and then set an expiration lifecycle policy specifically for non-current versions to expire in X amount of days, right? So maybe I want to have the ability to retrieve and roll back for 90 days, right? So I perform a mistake, I have 90 days to actually roll back. So you can do that by combining lifecycle policy, expiration action, along with versioning. Another interesting sort of feedback we heard from customers is because I use versioning, I have versioning enabled, and I have an expiration policy to remove my non-current versions as well. It is possible for me to issue a delete command and not have a current version, and then over time, the expiration policy goes ahead and removes the non-current versions under me. You now have an empty delete marker. So the way this works is if I issue a delete command instead of overriding, S3 will place a delete marker to signify that the latest version has been deleted and not remove the other versions. And then Lifecycle can come in and then remove the non-current versions based on the policy that you have set up. But the implication of that then is over time, it is possible for you to have delete markers for objects where all the versions have been removed based on the policy. Now that is something customers can list, and you can actually go ahead and remove that yourself. But again, true to the spirit of lifecycle policy, we want to take that overhead away from customers, and this housekeeping you can simply do by specifying a new lifecycle policy to remove expired object delete markers. So there's 2 different use cases there. One is if I use lifecycle to actually delete existing versions and previous versions as well. So that's the example I have here, where I set an expiration policy and say I want to delete objects once they become 60 days old. But because you have versioning enabled, S3 is not going to delete it. It's simply going to make it the non-current version and place a delete marker on top of it. Then I specify another action where I want to expire non-current versions of my object in another 30 days. So in the first 60 days, an object will be deleted. 30 days from then, the lifecycle policy will delete the expired version, the non-current version of that object, and all you have is a delete marker. Because you're using the lifecycle policy to do this, we're going to do the right thing, and we'll simply just clean up that delete marker once all the versions under it are actually removed. There's another version of this where I do not leverage the expiration policy to remove objects, right? It's possible that my application needs to issue a delete command specifically. However, once objects are removed, I want to have the recycle bin functionality for 30 days, right? Have the ability to recover for 30 days. So in this case, I set the non-current version expiration policy just like I did in the previous one for 30 days, but I do not use lifecycle. My application actually issues a delete itself. In this case, there's going to be a delete marker which either the application and the customer needs to remove, or you can now specify this additional property, which is an expired object delete marker. Just set it to true. If you do have a delete marker with no versions under it, lifecycle policy is simply going to do that cleanup and housekeeping for you. All right, so let's take a look at how you might use the UI to actually go and set up this expired object delete marker policy. All right, so for any given bucket, if I go to properties for the bucket, under lifecycle, I can actually add a new rule. For previous versions, so for previous versions, if I want to delete these, let's say in 30 days over here, I now have this checkbox, this option to actually go remove the expired object delete marker and do the housekeeping for me, so I don't need to worry about doing it myself. Right? So that's how simple it is. You can simply specify that, and S3 will then take care of it for you. The implication of that, of course, is specifically you get better list performance if you do not have delete markers, right? So if you had hundreds of billions of objects, and a lot of those are actually delete markers, right? Because you keep deleting those and adding new data. Over time, when you list, we actually filter those delete markers out, and that takes a little bit of time. So if you remove those and you do that housekeeping, your performance of your list API actually gets, you see improvement in that performance. Another best practice, again, to protect against those accidental deletes is multi-factor authentication. So that's something that we support in S3. You can configure this at your bucket level so that in order to successfully issue a delete command, S3 will actually not only require your security credentials, but also will require the code from an approved authenticated device. Yet another way for you to protect yourself against those accidental deletes, whether it's an issue in your policy or just an accidental delete by a user. So you can set up versioning and the recycle bin functionality with versioning and lifecycle. Here's another way that is recommended for you to protect specifically the data. You want to make sure that you want to double check that you actually want to remove that data. All right. So with that, let's talk a little bit about some of the best practices around improving performance of your workload and application on S3. So one of those is really the ability to parallelize your put API calls, specifically for larger objects. You have the ability to break that object into multiple parts and actually upload those parts in parallel to get much better performance. For instance, if you're on a high bandwidth network, you can actually get much higher throughput on aggregate throughput on your network by breaking your object into multiple parts and actually uploading that. If you were doing, for instance, a big data job like we were, this is an optimization that you can do if you have a lot of data that you're moving around. Also for networks where the network resiliency is lower, for spotty networks, right? In that case, you want to make sure that for a retry, you don't upload larger objects again and again. So if you break your object down into smaller parts, you add resiliency to your network because one specific part might fail, but that's the only one that you need to upload. You don't need to upload the entire object. Now, multi-part upload, the way multi-part upload works is that you can break these parts down in smaller chunks and upload those. And once you've completed all of those, you can issue a command to actually put the object back together, and S3 actually exposes that to you as a complete object. However, we've heard from customers that depending on my application, there are cases when either my application might die or run into an issue or throw an exception without having uploaded all of the different parts. So now I ended up with multiple parts that I am actually paying for. You are charged storage costs for each of those parts, but I never really completed those. Now you can list those individually. By default, list does not show them, but you can specify a parameter to actually list incomplete multi-parts as well, and actually clean those up yourself. But again, why do that when Lifecycle can actually do that for you? So which is why we really introduced this new policy for incomplete multi-part upload expiration policy, where you can tell Lifecycle to simply delete all parts if upload has not completed in X amount of days. So here's an example of the policy. In your Lifecycle policy, you can specify the rule to abort incomplete multi-part objects, and all you need to do is specify how long should I wait, right? How long do you expect your multi-part uploads to take? And you can simply specify that in terms of days, and S3 will then, the Lifecycle policy will then delete all the multiple parts that have not completed, the multi-parts that have not completed in that many days. So you don't need to worry about that cleanup, and of course you can restart that again. Another best practice is, in addition to parallelizing your put request, you can also parallelize your get request, right? You have the ability to do range-based gets on your individual objects, specifically for those large objects. So you can actually benefit from, you can actually spin multiple threads up and get higher download speeds, right? And download larger objects quicker. This, again, compensates for unreliable networks as well, because if you are downloading smaller parts, if it fails, you only need to retry for that specific part and not download the entire object.
Apologize.
All right. So we looked at parallelizing your get as one of the best practices. Right. Another thing you can do is parallelize your list requests as well. So you can do multi-part upload and upload specific parts. You can download specific ranges of your object. And then you can also parallelize your get request, right? Specifically, if you want a sequential key for a sequential list of your keys, you can then pick specific prefixes and start multiple list requests, because list request is paginated. You can get up to 1,000 objects per request. So you can actually start multiple requests with the right delete markers for multiple prefixes or even within the same prefix. Another very common usage pattern we see from customers is using secondary indexes, right? Specifically for list, right? I can maintain a secondary index, and then not only that does that get me faster list, I also have the ability to sort and search on metadata, which in a lot of cases can be very useful. Another best practice is around SSL, right? And really, for all of these different best practices, if you can, you should just use the SDK. We make sure that we continually update and optimize the SDK to leverage all of these where possible. But of course, you can't use that every single time. And so if not, please be aware of these best practices. They can really help you optimize the performance of your application. For SSL based, if you can use hardware that's optimized, and you can use hardware acceleration for SSL encryption, that can really help you get the most, right? Because there is overhead in encoding all of these in software, and doing the SSL encryption in software. Also, the handshakes are expensive. So if you can avoid these handshakes by performing keep alives, or pooling connections, sending multiple HTTP requests, HTTPS requests over the same connection, and not having to set up these expensive connections every time, again, is a way you can actually optimize your application and improve the performance. Another best practice is making sure that your key names are randomly distributed. And that really kind of comes from, is relevant for buckets that you expect high TPS, expect to drive high TPS against, around 100 TPS or more. We see a lot of customers naming their bucket in this similar to this example, where maybe I have my bucket and then I have date ranges, year, month, day, and then I break down my data. The problem with this is that if you have your keys in this sequential manner, S3 is going to try and write these keys to a specific partition, right? Because these need to be located together. But because you don't have that randomness, all of the uploads that you're doing go to the single partition. Now, S3 does distribute workload under the covers, but if you expect your workload to spike very, very fast, you might see higher turnaround times. So the best practice really is to get as much randomness as possible as soon as possible in your prefix, right? So right after your bucket name, if you can randomize the first few characters of your key name, that then generates the randomness, and when you upload these, they're naturally going to show up and get uploaded to multiple partitions in S3, which makes sure that you do not see higher turnaround times when you hit higher TPS. So some of the techniques we see customers use, you can hash your entire object name, entire key name. It's important to know that this is the key name, not just the file name, right? So if you do have bucket 1, prefix 1, 2, and your file name, image.jpg, all of that is considered a key name. So you need to make sure that right after the bucket name, you hash everything, including the prefixes. Another sort of technique is to prepend a key name, the key name with a short hash. Or you can actually reverse the key name if that makes sense. But again, the goal is really to make sure that right after the bucket you have as many random characters as possible, which will then ensure for high TPS workloads, they randomly get distributed across the multiple partitions in S3, and you don't see higher turnaround times. So there was a lot of information we covered. We looked at standard infrequent access. We looked at the great demo Carl put together for us to really take access logs that we have and use that information to determine which one of my specific prefixes are in fact infrequently accessed. And then we set a lifecycle policy to go tier those, specifically those prefixes, to SIA, because now we deterministically know that those prefixes are infrequently accessed. We looked at lifecycle policy and the new management capabilities we've added to lifecycle policy for expired object delete marker as well as multi-part upload. We looked at versioning and some best practices around that, as well as some best practices around performance. So with that, we're going to end. Again, Carl and I are here for any questions. We encourage you guys to come over, chat with us, give us your feedback. But thank you for coming.